Simon, hypermill, you push machining to the limit. I can see that the evidence is there in this aerospace structure component. Can you tell us about how you machine it? Because to me it looks like I wouldn't even begin to know what sort of tooling to use and the process.
Looking at this part, you can see there's a large amount of material removal here. In addition, we have very deep pockets with very small radiuses in the corners. These are 5mm, so you had a double problem there where you've got to remove large amount of material in a very short space of time, but also get inside these long walled sections, these pockets, using tools with very small radius.
So how did you go about doing it?
Well, we use a combination of tooling here, Paul, to remove the material as fast as possible. We used standard roughing tools, but we used one of our strategies called 5-axis helical drilling. The advantage of the helical drilling, it enables you to use standard tooling, standard roughing tools, but it also enables you to choose much shorter tools, which gives much more rigidity when removing large amounts of material very fast. So that was really the tools that we used to remove the material as quickly as possible. The 5-axis motion allowed us to tilt the head over in a helical action to avoid collision with the tool spindle against the part itself.
It's the use of barrel tools.
Yeah, the use of barrel tools we used not only for the roughing process but also for finishing as well. You may be able to see here that the witness marks left by the tooling suggest that we took very large, big step downs down these pockets. Conventionally, you would have to use a ball nose tool to flick it over at an angle to avoid again the collision with the tool holder, and the corners would obviously cause problems because these are small radiuses in the corners and they're also very deep. With the barrel tool, which is a conical tapered tool, in this instance with a tip radius on the bottom of the tool, it allowed us to flick the head over. The very nature of the shape of the barrel tool allowed us to take quite big step downs of 6mm compared to a ball nose tool where we probably would have had to step down at 0.1, 0.2 of a millimetre. So we were removing material much faster, and at the same time it was allowing us to pick out these 5mm corner radiuses in each corner of the pocket much faster than conventionally going down there with a ball nose tool.
So you're almost doing two jobs in one.
Exactly, yeah.
And hence the reason you get the cycle time of 2 hours, 15 minutes to machine this from start to finish.
Yeah, quite. If we'd have used standard ball nose tools, we would not have achieved that kind of time. It probably would have been treble, maybe 4 times the machining time. But you know, again, the use of barrel tooling is barrel tools have been around for a number of years now, but it's only recently where, you know, cam innovators such as OpenMind with hyperMill have allowed you to use that clever technology in its toolpath strategies to utilise the use of using barrel tools and the benefits that they bring.
So we really are pushing machining to the limits, as hypermill says.
Yes, we are, Paul. Absolutely. What I haven't told you is that the 2 hours 15 minutes also includes 5-axis chamfering on every single face across that part, which is why I'm handling it without ripping my hands to pieces.
So you mean I can't have a shave with it?
Unfortunately not, no.
Thanks for your time today, Simon.
Thanks very much, Paul.